So in the previous video, I talked about various advanced features of C. We learned about the realloc function, where you could reallocate memory and change the size of an array, and then how to use that to be able to read a string of arbitrary length. And this week, I wanted to continue that discussion about some advanced features of C, especially some features that you're probably going to be seeing in other people's programs. And if you're going to use them in your own programs, you need to be very careful because you can introduce some very subtle and interesting bugs. So let's start with that. So I want to talk about first how to increment and decrement variables. So I've been very careful up till now that when I do an increment or a decrement of a variable, I'm always writing out a full statement. Let me actually start a program here just to show what I'm talking about. So I'll start a new program called increment.c. And we'll do the include standard IO. And probably just spell that right. And then my main function, this is just a demo program, so I don't need to read from the command line. So I've always done things like for I equals 0, I is less than 10, I equals I plus 1. I've always written for loops like that because I'm trying to be very explicit about how I'm incrementing my variable. But there's other ways to do that. There's actually a shorthand where you don't have to write I equals I plus 1. You could write I plus plus, and that will increment the value of I by 1. Or you can do plus plus I, which will do the same thing. It'll actually increment the value of I by 1, but putting plus plus before or plus plus after does it in a slightly different way that, if you're not careful, can introduce some very interesting bugs. By the way, you can do the same thing with plus plus and minus minus. So let's go ahead and do a simple program here. We'll do two variables. A, we'll just initialize that to 0, and B, we'll also initialize that one to 0. So we'll go ahead and print our values. So we'll print the values of A and B. And we'll go ahead and say printf A is this value, and printf B is this value. And so at the beginning, those should both be 0. Let's go ahead and demonstrate that plus plus. So we'll do printf A plus plus is this value, and then we'll say A plus plus. And then printf plus plus b is this value. We'll do plus plus b. And then I just need to print the values of a and b again, so I'm going to go ahead and copy and paste my code that I had up here. Copy and paste. And then return back the operating system because I'm done. So let's take a look at what I've got here real quick. And we'll talk about what we should have. So A and B are both 0 at the beginning of the program. And then I've shown two different ways to do plus plus. So A plus plus, so when you put the plus plus after the variable, that's shorthand to tell C that use the variable's current value, and then when you're done, increment the variable by 1. So really what's happening is by the time C has reached this paren, it's going to increment A by 1. But it will have used A plus plus. It'll actually have used the current value of A, so 0. So what we should see in the program is A plus plus is 0. Down here, we've done it that way around. We've done plus plus B. And so that means it's going to increment B by 1. That's what happens when you do plus plus before the variable. It's going to increment the variable by 1 and then reference the value. And so we should see plus plus b is 1. Now, when they're both done, they've already incremented both by 1, and so at the end of the program, both A and B will be 1. So let's go ahead and try that sample program. And I16 GCC. We're going to turn on all warnings. I'm going to save this as increment.exe, and we're going to compile increment.c. If I don't have any errors or warnings, then I get prompt back, and we can go ahead and run increment. So you can see at the beginning, A and B both start at 0, and A++, it pulled the current value of A and used that for the printf statement. And then when the printf statement was done, it added 1 to it. And then plus b, it added 1 to b first, and then used that value in the printf statement. And so at the end, both of them were already incremented by 1, and that's why at the end of the program, both a and b are 1. And you can do the same thing with minus minus. So if I go up here and edit that to minus minus, over here, I'm going to change this to minus minus, minus minus, minus minus, minus minus. So what have I done here? All I've done is I've changed the plus plus to a minus minus. So a minus minus is going to use the value of a in the printf statement, which is 0 at this point, and then it's going to subtract 1 from it. So at the end of the printf statement, basically by the time it's hit this paren, it will have subtracted 1 from a, but it used 0, the previous value, in the printf statement. Down here, minus minus b, it's going to subtract 1 from b and then use that value. So minus minus b should be a minus 1. And then at the end, both of them will have 1 subtracted from it, and so we should have both a and b being minus 1. Let's go ahead and compile that to make sure we get the right values. And if I don't have any errors, I can go ahead and run my program. And you can see that both a and b start out at 0. A minus minus is going to use the current value of a and then subtract 1 from it after it's done. And then minus minus b is going to subtract 1 from it and then use that value. And so that's why at the end both a and b are minus 1. And so you can use this in your code. You can need to be very careful, I would say, about using that in your code. So if you're going to use it in a for loop, like in place of the I equals I plus 1, or you just use I plus plus, you can use either plus plus I or I plus plus. But if you're going to do it in an if statement, be very careful about how you're going to use that if statement. Generally, I try to avoid using plus plus as part of an if statement, because what you're doing is you're basically modifying the value of your variable kind of as you're testing it. And yeah, that'll be a good thing to do if you in certain circumstances, but in most cases it's gonna lead to a very interesting and subtle bug. So I would recommend in those cases just doing a plus plus or a minus minus on its own if you need to actually increment it or decrement it by 1. And so that's the shorthand for how to do increment and decrement. Now, another thing you're going to see in a lot of C programs is binary. And so let's go ahead and show a little bit of binary. Let me first talk about something about base 10 numbers, just before I start about binary. So when we talk about base 10, we don't really think about it because we grew up with base 10. So you might think about counting from 1, but really you count from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's no single character that represents 10. Because in base 10, we have the ones column, and then we have a tens column. And to the left of that, we've got the thousands and so on. So to write 10, you write it that way, right? Because when you think about it, what you're doing is you're saying that's 1 10 and 0 ones. And it seems obvious to say it, but because we grew up with counting numbers that way, we grew up with the base 10. But that's not how computers store numbers. If you store a 9, you're not actually literally storing a 9. The computer has to store that in a series of zeros and ones, and that's a system called binary. So every time you deal with binary numbers, let's go ahead and just get rid of this. Binary numbers kind of look like this. So you got, in this case, a series of 8 bits, and so a bit is going to be either a 0 or a 1, and 8 of them together is a byte. And if you're going to do all zeros, that means that that's 0. If you're going to do a 1 in that ones place, that's going to be 1. And so what are we looking at? This in a base 10 system, remember we went from 0 to 9 in this first column, in this last column rather. In a base 2 system, which is binary, you're going to have a 0 or a 1, and then you need to move on to the next column. So this is the ones column, this is the twos column, This is the 4s column, the 8s column, and so on. So just like in base 10 counting, they went up by powers of 10. Here they're going up by powers of 2. The 1s column, the 2s column, the 4s column, the 8s column, and so on. So what does 2 look like? 2 is going to get stored like that. And 3 is going to get stored like that. And so on, right? So 4 is going to be stored like that. And you can see how the computer is storing these different numbers through binary. So that's actually what's being stored on the back end. And so how do you use binary? Well, they actually wind up showing up all the time. They're very, very useful in computer programming. If you think like a computer a little bit when you're programming, it can kind of help. So let's talk about some things you can do to operate on these binary values. So let's just do a simple program here. Let's do a include standard IO in my main function. I don't need to do anything on the command line, so I'm going to have an empty parameter list. And I'm going to do a let's just have two variables here. We'll do an int a, and we'll store the value of 1. And then int b, we'll store the value of 3. So remember, what's being stored? Binary. Let's only show the last couple of bits here. So we're seeing for 1, it looks like that. And then for 3, it looks like that. And so how do we use those values? So when we did if tests, we did a logical if we combine that with a logical and or a logical or. And so if something is true or something else is true, then the whole statement is true. If something is true and something else is true, they both have to be true for the whole statement to be true. And you can do the same thing binary. And so you can, what that does, that actually operates sort of, if you line up these bits, if both of these are 1, the binary and will be a 1. If you do an or, well, then at least only one of them has to be a 1 for the final value to be 1. So think of it as true and false. So let's actually kind of show that. So let's go ahead and start. We'll just show the values of a and b. A is that value, and b is that value. And let's remind ourselves as we do this here. So binary goes like the 8's place, the 4's place, the 2's place, the 1's place. And we'll remind ourselves here, the binary of 1 is 0001. Actually, I'll have a whole bunch of other zeros in front of it because normally it's stored in a different size than just 4 bits. But that's all I'll do here. And then put s, the binary of 3 is, and let's remind ourselves what that is, right? That was 0011. And so now to do the binary operations, A and B. So before, when we were doing our if tests, we would use 2 ampersands. Well, to do a binary and, we want to do a single ampersand. So A and B, oops, A and B is what number? So we'll do A and B. You don't have to, you could have a space in between there if you wanted. You don't have to. And then printf. So let's do another one here for an or statement. So A or B, because remember we did an if test and we'd say if this or that, we'd have the 2 vertical bars. Well, here we want to do a binary, and so we're going to do a single vertical bar. And that is that value. So we'll do A or B, binary or. binary and. That's all we need to do here. Let's do return 0. Now let's remind ourselves what we are doing here. So we've got the value of 1 in the A variable, and we've got the value of 3 in the B variable. And so this is what that looks like binary. And so what would we expect A and B to look like? Well, if you look at each column, the only places where they both have 1 is in that 1's column. And so that value should be 0001, which is 1. The binary of A or B, so which column has at least one 1 in it? Well, the last 2 columns have 1s in them. So I would expect the value to look like 0011. And that's going to be 3. Let's go ahead and test that. Save and quit. And we'll go ahead and compile that. I16 GCC, turn on all warnings. We're going to output that as binary.exe, and we'll compile the binary.c file. If I didn't have any errors, which I didn't, good. Let's go ahead and run binary. So there we go. So we got 1 and 3, because that's what we expected A and B to be. So if we edit that again, binary.c, we might change this to be a different kind of value. The binary of B, well, let's make that value, let's make that, we'll make that 5. So what's the value, the binary value of 5? That's going to be 0101. And then remind ourselves what that is down here. So the binary of 5 is 0101. So what does that mean when A and B? So again, only the last one is going to, the last column, the 1's column, is going to have a 1 in both positions. So A and B should still be 0001, which is 1. But what's the value here for A or B? Well, it's going to be 0101. So that'll be 5. So let's do a compile on that real quick, and then run that program. I would expect it to be 1 and 5. And there we go. It's 1 and 5 because we're doing our binary tests. Now, there's other things you can do with binary that are extremely useful. So I'll in the programming guide, I'll also include some other things that you can do operator-wise, like flipping the values between 0 and 1. That's a not statement, or the exclusive or is also sometimes a handy thing to do. But bit shifting is a really useful thing. So let's bring up our binary program here, and let's shift some values around. So how do you do a binary shift? Let me just get rid of these 2 statements here. So it can be useful sometimes to take the binary values and move them left and right. So if I wanted to move A, all the bits on A left by 1 position, what's that going to do? So first of all, let's remind ourselves, let's tell ourselves how to do that. So to move the bits around at the binary level, you're going to do the variable name and then less than, and that'll tell it with this less than you're doing a binary shift. And how many positions do I want to move the bits? Well, maybe I want to move it just by 1 space. And so what does that do? That's what value is that going to give me? And do A minus less than 1. So that value, what would I expect that to be? Well, if I look at what I've got here for the value of A is 1. If I move all of those left by 1 and then sort of backfill on the right with zeros, I expect that to look like 0010, which should be 2. And if I do a printf on B shifted left by 1, what is that going to be? Well, that's going to be b less than 1, that should look like 1 0 1 0. And so that should be, if you do the math, right, that's the 1's place, the 2's place, the 4's place, the 8's place, and so 8 plus 2 should be 10. Let's go ahead and run that program. And if I don't have any errors in there, then I'm good to go. So we'll go ahead and run binary. And you can see that we've got 2 and 10 because I've just taken those bits and I just shifted them off to the left. You can do the same thing going off to the right, and I'll just show that one more time. So we'll do edit the program, and rather than shifting off to the left, let's go ahead and shift to the right. So what does that look like when we shift all the bits to the right? So you're basically taking these bits and you're going to shift everything to the right. Well, that means you're going to lose whatever's on the right hand side. That's just going to disappear. So what's left? Well, you've lost the 1, so all that's left are the zeros. So you're going to have a binary value that looks like that, which will be 0. And if I'm going to do B shifted off by 1, so that means I'm going to lose the 1, because I'm going to lose, everything's going to be shifted off to the right by 1. The thing that's in the 1's place just goes away, and then what's in the 2's becomes the 1. What's in the 4's becomes the 2's. So that number, when it gets shifted around, is going to look like 0 0 1 0, which will be 2. So those numbers should be 0 and 2. Let's go ahead and compile that. And I don't have any warnings in here, so let's go ahead and just run binary. And you can see, oh, I've got a bug in the program. I edited the print statement. I didn't actually edit the code itself. So let's go ahead and fix that. Greater than, greater than, greater than, greater than. Okay, and save and quit, recompile the program, and now rerun it. So I would expect this to be 0 and 2. And there it is, 0 and 2, because we now just shifted bits to the left, and we know how to shift bits to the right. And that's very useful. Being able to shift bits around and being able to compare based on bits that are there makes it very useful in writing programs. And so let's talk about another thing that's useful in programming. And so we've been talking so far about variables holding a single value or a single kind of value. So we have, integers and floats, or we've created arrays of those, and that's just an array of a single kind of value. Well, you can actually create variables that have more than one variable stored in it at one time. So what do I mean by that? Let's actually write a quick program to show how to store more than one kind of value in a variable at a time. So you do that with structures. So I'm going to go ahead and create a new program here. Let's call it struct.c. And there's my include standard IO and my main function. So how do we do structures? Well, you're going to do structures with the keyword struct. And inside these curly braces, you're going to actually define what that structure looks like. So what's inside that structure? So if I'm going to be doing a program that needs to store X, Y locations, because I'm doing maybe a grid coordinate, I might want to have floating point values for X and a floating point value called Y. Now, just like I would normally define variables, right, they have the semicolon at the end of that statement, and I've got, just like I would normally do a variable, I would say the variable type and the variable name. Now, at the end of the struct, I actually want to say, okay, this is a structure that is combined of that, and I want to have a variable that I'm going to just reference, and we'll call that one, let's call it Qsort. So now I've got a variable called Qsort that has an X and a Y component. So how do I store values in there? So let's actually store some values in there. So Qsort chord.x. That's how you reference the value of a structure or the component of a structure. So use that dot to say that variable, which is up here, and then this part of the structure in that variable, which we defined up here. So chord.x, and we'll just give it a value, a floating point value of, let's say 10. And then chord.y is, we could do like 1.5. And let's go ahead and print those values out just to know that they worked. So we'll do a printf. We'll say xy is, and then a floating point value, comma, floating point value. Oops, and then we'll do a new line. And then I'll do chord.x and chord.y. And that's all my simple program is. We'll just go ahead and return back the operating system, oops, with a 0. And save and quit. And we'll do an i16 GCC. We'll turn on all warnings to make sure I didn't make any errors. We're going to save that as struct.exe, and we're going to compile struct.c. And if I didn't make any errors in my code, then I get a prompt back, so I can go ahead and run struct. And you can see that it's I stored 10.0 and 1.5 as my x and y coordinates, and that's and I was able to pull those back using chord.x and chord.y, and that's a very useful way to combine variables under one sort of parent variable. What you'll see, the way you'll see this used most often, let's go ahead and bring up that that program again. The way you'll see this used most often is rather than defining a struct as part of the variable definitions, you actually can do what's called a type definition. So normally the variable types are things like ints and floats, right? And chars, we've done that before. But you can also do a type definition of your own that defines something like maybe you want to have a Boolean value, and so you might have like a short, which is another type of variable, and you're going to name that as Boolean. Or you can do it with structs, and that's a very handy way to do things. So we can do a type def on an entire structure as something else, and so let's call it chord. Let's actually, you normally have seen these underscore t's in some of the programs that we've done, and I've said you can just treat that like a normal variable type because they've done behind the scenes this type definition. So for example, elsewhere we've seen size underscore t, and here we're doing a chord underscore t. Because we're just going to define this as our own type definition, and we're basically going to define our own variable type. And a handy way to remind people is that when you're writing your programs, because remember the program source code is really for you, we're going to remind ourselves as a type def by putting underscore t at the end. You don't have to, but it's a common nomenclature people will use. And so what's in there? It's going to be a float value for x and a float value for y. And so now when I do my variable definition, I can just say, rather than having to put in that whole big structure, I've already got the shorthand now, and I can just say chord underscore t, that's the variable type, and now my variable name, which I'll just call chord. And that's all I need to do. The rest of my program remains the same. And I've just made a type definition up here at the top that says type def for this structure, this entire structure. We're going to reference that as a variable type that is called chord underscore t. Up here we've got Boolean, which has been defined as basically a short value. And most of the time I'll use type def, so I'm doing some sort of structure, but you'll see lots of other cases where you'll have a type definition calling it some other short name. Just so I don't confuse myself, I'm going to go ahead and get rid of that. Let's go ahead and compile the program that I've got, and do a i16 GCC, turn on all warnings. We're going to output this as struct.exe, and we're going to compile struct.c. And if I didn't make any errors in there, which I don't think I did, I get my prompt back, so I can go ahead and run struct. And so it's the same thing, right? So I've defined a type definition at the beginning of my program, and then I've used that type definition to make a variable of type Qsort underscore t. That's my own type of variable, and you can use that if you're going to be doing storing data that's going to have lots of different components to it. Here I'm using it as XY coordinates. You also might do that if you're going to involve maybe complex numbers, which have a real component and an imaginary component. There's lots of different ways that you can use these structures to store different types of data in sort of one variable. It's a very handy way to do it. You'll see that, for example, with time, when you capture time, because it'll have different types of, like the hours and the minutes and the seconds will all be captured as different fields in that structure. Now, one other thing I wanted to show is how do you do sorting? So we've talked before about how to create arrays and how to put variable data in those arrays, but I haven't talked about how to sort that. So sorting arrays, sorting a list, is an extremely powerful thing that you can do in any kind of programming language. And yeah, you can absolutely do that in C as well, but it has a specific kind of calling syntax because you're, well, you'll see. So let's go ahead and do a simple program here to demonstrate sorting. So the concept, let's do a sample program here, fed sort.c. So we're going to be using a function called Qsort, and if you look through the library definitions on your C compiler, you probably have seen this, but it's got kind of a weird calling syntax, and so you may not have figured out how to use it yet. So here we're going to learn how to use it. So Qsort basically is going to say, I need to see what values you want me to compare. So it might be like A and B, but it also needs to know how to compare that. And so there's a function you're actually going to give Qsort. Now there's different ways to sort things. There's bubble sort and things like that. Qsort is actually a pretty fast sorting method for a lot of different types of data. So Qsort is the standard sorting function that is included as part of the C standard library. So let's go ahead and use that. We're going to do a sample program here. We'll do an include standard.io.h, and this Qsort function is part of the standard lib. So we need to do include standard lib.h. I'm going to have my main function, and I'm not going to be doing any command line parameters. So I'm going to go ahead and write a simple program here. Let's make an array. I'm going to use the size a couple of different times. Let's go ahead and make a parameter. Define. We'll just call this array size. This doesn't need to be very big. We'll just call it 10. But that way, if I need to change the size later on, I could do that. So let's go ahead and make an array of just fixed size. Remember, we do that. We don't have to do arrays through malloc. We can actually just do an array of fixed size when we define the program and just say int array. And it's going to be of size array size. And I'm going to need to loop through this, so I might as well make a variable called I. I'll just loop through that. Now, I want to be able to store some random numbers in the array. So let's go ahead and store some random numbers. So I'm going to do, remember, I'm going to do the rand function, but before you use rand, you really should seed that random number generator, and we can do that with srand. And you can pull the system date, and I'll make sure that shows up in the programming guide, but just for simplicity here, let's go ahead and just pick a number, and we'll just use that as our seeded value. And now I'm going to go ahead and run through my array, so we'll do a for. I is 0, because that's where all arrays start counting at 0. I is less than the array size. And then I equals I plus 1, or I plus plus, or plus plus I. And I'm going to go ahead and store a value in the array. That's a random value. So array I is random. And just let's make it a number that is easy to see. So we'll just do a modulo of 100. But remember, I need to make sure that's going to be in the size of an int. So we'll go ahead and do that. Just so I can see what I'm putting in there, let's go ahead and immediately print that out. So we'll go ahead and do a printf, an array, and then that index in the array is that number. And so the index of the array is I, and then the number itself is array I. So that's going to now print out the array before the array is sorted. So I probably should put a little note up here that says, put S, before sorting. And now let's go ahead and sort the array. So how do we do sort? We do, as I said, we do it through Qsort, which is basically a quick sort. We need to tell it what array we're going to have. So we're going to say, I know before I said, it's A and B. It's really actually how you compare. You need to say, okay, this is what I'm going to be. I want you to sort this array. And how big is that array? Well, that array is going to be of size array size. And then how big is each thing in the array? And so I need to have a size of an int, because that's what each thing in the array is. And if you had a type def, right, that's where type def becomes important. Size of whatever you're using for your type def variable. But in this case, it's just a plain int. And then I need to give it a function, actually a pointer to a function, which I haven't written yet. And so we'll do that function as compare num. Before I go any further, let's go ahead and write a compare num function. We'll do that up here. So we'll do a function that is, we'll do it as an integer function, because that's what it needs to be, and we'll do compare num. And that's where we're going to say, okay, it needs to know two variables. It needs to know A and B. So what is A? A has to be a variable. Now, what is the variable type? Well, when Qsort is using this, it actually doesn't really care. So we need to remember when you have a variable that is of any kind of variable type, it's going to be a void variable type. And in fact, this is a variable type that we know is not going to be changing, and so you use the keyword of const. And we're not actually passing the specific value itself, we're just pointing a pointer to the value itself. So it's const void star A. That's a pointer to a variable that we're going to call A. Same thing over here, it's a const void star B. And then my function itself is going to say, okay, I'm going to compare these two values, just so we're not pulling the things differently. Let's just make it clear here. We've got two variables. We'll call it A1 and B1. And A1 is going to be stored as the reference to the variable A, and B1 is going to be the reference to the variable B. And the rule for the comparison function is if the first number, A1, is less than the second number, then you have to return a negative number. So we're going to just return, in this case, -1. Or if A1, the first one, is greater than, up here I bug, if the first number is greater than the second one, then you need to return a positive number. Well, here let's return a +1. If they're the same, so I can just do an else in this case, if they're the same, you need to return 0. Now, by the way, you could do this using subtraction, which is how you see a lot of people do this. Here I'm just going to do this if-else block so we can actually see. Oops. That's else if. So I'm just going to do this if else block so that we remind ourselves very clearly if the first one is less than the second one, return a negative number. If the first one is greater than the second one, return a positive number. Otherwise, if they're the same, return 0. Now, as I said, you could just do return A1 minus B1. That would work as well in here, but here I'm just going to do a very clear positive and negative value. And so now I've got my function called compare num, and that's been written so that I can compare two numbers that come into it. And then I'm using that here in the Qsort function. And let's go ahead and now print the values after it's done. So we'll go ahead and do print values. And we'll just say put s after sorting. Oops. And we'll do our for I equals 0. I is less than the array size. And do I plus plus. And we'll just do a printf that the array at that index is that number. And so the index is I, and the number is array I. And so now I'm printing out the values. Let's go ahead and print it out. And probably should return back to the operating system with 0. Let's go ahead and run that program. So save and quit. And let's do I16 GCC and return on all warnings. We're going to output this as sort.exe, and we're going to compile sort.c. And if I don't have any errors, I don't, go ahead and run sort. And you can see that before I've sorted the program, before I sorted the numbers, I had random numbers between 0 and 100. And you can see they're all in different orders, just random order, because I was picking random numbers as they went. And then I did the sort. And now my list is in an ordered list. And so that's how you use Qsort. It's all about writing a function that's going to compare two values, and it's going to return a -1 or a plus, well, a negative number, a positive number, or 0, depending if it's less than or greater than or the same values. And so I want to stop there. That's those are some advanced features of C that will help you in your C programming. And let me know in the comments if there's other things you'd like me to cover, but I'm going to go ahead and pause there. But before I quit, I just want to thank everybody who's supporting me on Patreon. You really do make this channel happen. Some of you are supporting me at a higher level, and I wanted to thank you specifically here, so thank you very much. And that's it for this week. So visit our website at freedos.org, join us on Facebook, follow us on Twitter, and consider supporting me on Patreon. Thank you.